deeply embedded in our mission, our culture now, is to try to push to a world where hundreds of companies can build this. And being open right now, sharing our research, sharing the weights while we're able to, while we're allowed to in this world, I think helps like push towards that.
How are you finding San Francisco?
It's good to be back.
Yeah.
I've been coming in and out of this city for, wow, over a decade now. And you kind of see it go through the cycles. You see how it changed, and it feels back, right? And with AI. And so I'm quite excited. Yeah. And plus it's a sunny day, which makes all the difference when the clouds aren't in.
So we were talking about this a little bit beforehand. Our amazing setup guys were telling us to look at each other in the eye. And it made me think about, we were talking about like eye contact and things like that. And there's funny San Francisco tropes around this. But it's making me think of, I'm not sure if you're familiar with the science fiction writer Asimov.
Of course.
Okay. I just started reading him, so I had never read him before. But I was reading one of his books, and it's about a distant future where agents are running so many things for humans. And so in this future, eye contact is considered kind of rude or very personal, intimate thing to do because your agents do so much for you. So like even interacting with another human being is almost like a social faux pas at that point. So that's what it made me think of when we talked about eye contact.
It's true. It has changed, right? Like if I, at least, this is always what people say when they get older, like when you were younger, but it does feel like, like the way you were raised and grow up was like, look people in the eyes when you're having a conversation. I think all of us, I definitely have become a little bit more just all over the place and a little bit less likely to do so. And so it's true. We noticed it when starting, but it's funny you start on the sci-fi book because a lot of the changes that happened for us at Poolside this year, we actually kind of relate to the notion of reading a sci-fi book. And it starts a little bit, and we actually didn't talk about this before, so you kind of set me up perfectly. So I do have to thank you for that. I kind of asked myself a question at the beginning of the year, which was like, okay, if we were pre-ChatGPT, like we're in 2021, and I was picking up a sci-fi book from the shelf, and it was going to be set in 2035. And it was the history kind of between the moment we were in and getting to 2035, like how would I like that book to read? And this year it's felt a little bit like that book started becoming a dystopian sci-fi novel, where we're going to look back on 2035 and say, and it was an oligopoly of 2-3 companies that had built artificial intelligence that have reached AGI, and everything economically valuable and everything scientifically interesting was running on these companies. And that to me started kind of making me, for the first time, frankly, a little bit more ideological, which I've never, frankly, been, at least not in our business, because we're now looking at a world where I think most of us can agree that the capabilities are continuing to compound. I don't think everyone does, but I think we're really looking at a trajectory now where AI will start getting more capable than us on the vast vectors, at least of knowledge work that we do, and that will end up in robotics and others. And in that world, intelligence starts becoming a commodity that is probably the most demanded commodity we've ever had, probably second to energy, or maybe even beyond energy, because it's a function of it. And I was never really comfortable with the idea that all of us are just then buying intelligence from less than a handful of players.
Mm-hmm. So you're trying to work towards really making sure that future does not happen.
Yeah. Look, first and foremost, because I think it's very easy for a founder to say, hey, I found ideology like along the way, as it's like at the perfect moment in the market to do so. I think first and foremost, we started this company because we believe in AGI, and we still do. And we wanted to do everything possible to work towards it and to build capable foundation models that could reach that. And so that's our overarching mission. It's what puts us place. But as we are now looking at the world, yeah, I would really like a world where we don't have an oligopoly on intelligence. And it started informing some of the reasons we started opening some of our models as open weight models.
Mm-hmm. Okay, I want to talk more about all this, but I want to take a step back for a second. You told me that so much kind of started for you from one article that you read. Can you tell me more about this?
So I was thinking about it this morning. I think I got nerd-sniped by Karpathy in 2015. So Karpathy wrote this article called The Unreasonable Effectiveness of Recurrent Neural Nets. And if I recall correctly, it was in 2015 when he wrote it. And you kind of started seeing the very first signs of what a language model could do. right? An RNN that was able to start spitting out some text and some code. And it was kind of coherent. Like it wasn't perfect, but you could see it. And I still to this day don't really know why that article captured me so much, but it instilled a very strong belief that neural networks should be able to generalize to anything and everything, and that language was key to kind of improving intelligence inside of them. And so literally months or weeks after reading that article, I pivoted the company I was building into a company that was focused on building language models on code. Sounds great today. Back then, no one cared. Okay. Right? This is 2015, 2016. And about 4 or 5 years of my life with a team of about 40 plus people. And at the time, it felt like an absurd amount of money, $12 million, and servers built in our office with, NVIDIA consumer GPUs that were gaming GPUs repurposed. We started training first RNNs, then LSTMs with attention, and then transformer models when they came out, all about code prediction. And so I kind of realized that now, 11 years later, I can kind of thank being here to the fact that somebody, and in this case, Karpathy, I think has done this for many people, put out an article that inspired me and to kind of go down this path.
You've been in this field since 2015. It must be like most people I know are just getting into it now, or maybe even 5 years ago, but you've been in it for a long time. Like, what has that felt like from 2015 to now?
Well, the truth is, I was essentially in this from 2015 till the end of 2019. Mm-hmm. Then life had some events, and I didn't stay in the field for about 1.5 years, right until ChatGPT came out, or a little bit longer than 1.5 years. And during those first 4 or 5 years, it wasn't a field, right? Like if you could we used to call it machine learning on code. And the amount of people who even believed deep learning was a viable path was tiny, and we would throw meetups in places like San Francisco or Argentina or Moscow, or kind of like these very small communities, and you get 10, 15, 20 people showing up who were excited about what this stuff could do. And so it felt like you believed in an idea that no one else believed in. But also looking back, that's why I have so much immense respect for the folks at Google and OpenAI and others. Along that journey, getting the conviction from that very little signal that you should be scaling up was something that we hadn't figured out back then yet. And so kind of working on it for 5 years, then being out of the field for about 2, and then ChatGPT launching, which brought me back into it, it's been completely different, right? The last years have been this incredible acceleration of progress in our field, and kind of seeing more and more people in the world agree that this is real. Right? 3 years ago, we were still arguing with people that these were not stochastic parrots. And I think today, when you see the long horizon work that these models are capable of doing in and more areas, I think that's entirely fallen away. And now it's, I think the level of excitement that all of us have of what the next years are going to bring it's never been higher.
Yeah. I do see, even 6 months ago, or even sometimes today, because I've worked as a software engineer for some time, I still know so many software engineers that are almost a bit in denial, like, oh, the AI is not that good at writing code. And it's like, I think your opinions will be changing. Those opinions will be changed more and more. But it's funny to kind of still see some of those narratives, right, where people aren't excited or kind of in denial, in my opinion.
Look, I think it's okay, right? I think it for everyone, when it touches your work that you've been doing for so long, right? I've been writing code since I was 10 years old. I'm kind of person who likes to geek out over Haskell and and seeing the thing that you attach your identity to, spent all your waking hours thinking about, and now all of a sudden I can write a prompt and I can see more and more places where it is so much more capable than me. I understand that people will have various reactions to it, but I think overwhelmingly software developers are incredible at adopting new technologies, right? We have a tendency to, at least, can't speak for everyone, but I definitely think we like to be lazy. When we find something that allows us to do, if we can automate it away, we will do so. And I think LLMs obviously are allowing for just this incredible speed up in terms of what you can build. It's not everywhere yet. I think it's a very jagged edge of intelligence right now with these models. Places where they massively excel and places where they still fall apart to almost surprise. But I think I always try to think back in 3 to 6 month increments. And if I look at the models today compared to 6 months ago, 12 months ago, et cetera, the slope and rate of progress does feel like you are living on an exponential, which I think is a hard thing for any of us to really internalize, but it does not feel like we're living on some linear path anymore.
Yeah, it is so true. It's hard to plan for much anymore. It seems like planning timelines and things need to be incredibly sped up or looked at differently.
Well, I think it's what I like about speed of progress is that it's a forcing function to ignore everything that doesn't matter, right? And if I think about that in context of Poolside, all that matters is the models. We're still behind. We're not at the frontier yet. So every single waking hour for us is how do we close the gap? How do we kind of increase the gradient of our progress to close the gap with the frontier? And so when things are moving so quick around you, it becomes very easy to say no to everything else that doesn't actually improve that vector. And I think this is not just true for foundation model companies. I think it's true for everyone in the industry right now. And so all of a sudden, it's like you get clarity. I think this was very different in the years pre kind of the LLM, capability raise. I think there were lots of SaaS companies, lots of things being built. Like there was a lot of stuff that where you could coast along or you could do 10 things at the same time. Now I think it's the opposite. Now, if you want to win in this industry, no matter where you sit in the layer of the stack, you got to do the one thing you do incredibly well.
So you're launching Laguna S, which is your open source model. Can you tell me more about it for people who don't know?
So I'm really excited about this model. It's for us a model that came out of the latest run of our model factory. So one of the things that kind of set us apart is that we obsessed over 3 years of the industrialization of model building. That ultimately you're going from data on one end to a capably evaluated model on the other end. And throughout that, it's a process of improving the data, a process of taking and ablating the latest architecture ideas that you have, newest post-training techniques, new synthetic data approaches, more RL environments. And we've really obsessed over how can we as a small team, because we're a small team. I was running the numbers the other day. We have about 70 people who you would call like an applied researcher. And then you have about another 30 plus, like pure just engineers who don't come from applied research background, although that line is blending very much these days. So less than 100 people have been focused on building the entire apparatus of building models. But Laguna S is a model that we started pre-training 8 weeks ago. And it's coming out 8 weeks later. It finished pre-training in under 4 weeks, and we spent about 3 weeks of post-training and 1 week of getting ready for release. That timeline of being able to build a capable model in 8 weeks is purely a function of like our time spent on really improving the apparatus and not treating the model as the artifact anymore, but like the factory that produces it. And the next model started pre-training yesterday, actually. And so it's this constant thing. So with that big preamble, Laguna S is a 118 billion parameter MOE with 8 billion parameters active. So it's a really nice weight class. It's not a very big model, but it punches far above its weight. Not just kind of what we see in the benchmarks that we've chosen to care about, which is kind of long horizon agentic coding benchmarks. So really the ability to, point the model at a problem and let it, continue to do the work until it succeeds. It's also a model that surprised us, in all honesty. We knew it was going to be a good model because it was a size up from the Laguna XS class, kind of similar architecture. But we started applying some of our kind of latest post-training techniques and some other advancements. And we were kind of surprised. It's kind of across the board in agentic coding and long horizon work, beating all the other open models that are its size, or in many cases, twice its size. And it just is a reminder again of how much more intelligence that we can squeeze out of, amount of gigabytes of bits effectively. And so I'm really excited about it. I also think that it is one that gives us a legitimate claim of being the first Western open weight competitor that is putting something out that in its weight class really surpasses what we see from other companies. But that might only hold true for a couple of weeks because in our industry, as you know, it's a moving target.
Yeah. Can you talked a bit about, the size, but can we talk more about like the architectural decisions that went into the model?
So before Laguna S, we released Laguna XS, which took end-to-end 5 weeks to build. And Laguna XS was the first of kind of our what we call our 2.1 generation of architecture. So this is a model that is a 3-to-1 ratio between sliding window attention and global attention. So it's really optimized for inference, which matters a lot sitting in the room where we're sitting.
Yeah.
So it's actually quite similar to the XS architecture. We sized up a few of the things inside of it. What I would say is that I think in the open weight space, I think we're all circling around the same architectures, right? Sparse MOEs, right? 118 to 8 billion ratio is quite sparse. More and more functions where we are trying to improve the attention mechanism with something that looks a little bit more linear, like sliding window attention. But not lose the advantages that you get from global attention. And then there's little tweaks that you'll see in the way that we do, like our rope scaling and our context length extensions and things that kind of focus on the type of long horizon tasks that we care about, so that the model is going to be more capable of remembering things from early on in its trajectory as it progresses. One of my favorite things about this model is that it's a million length context, which is just a really nice context window to work with, particularly on these long horizon tasks.
Poolside is an American open source lab, which is really exciting. But you weren't always open source. Can you talk more about what led to this decision?
Yeah. So when we started the company, it was very straightforward. Our view was AGI is going to happen. Reinforcement learning is going to play a major role in large language models. Today, very obvious. 3 years ago, almost heresy to say. And we kept our heads down, wanting to become and really focus on one of the companies that was going to achieve that. That's not changed. But what did change is at the beginning of this year, we looked around and we said, well, how's the world shaping up? And the world was shaping up into an oligopoly of intelligence. A few companies who were going to, frankly, run away with progress on models, and a world where all of us were going to be buying intelligence from 3 or 4 players. And it didn't sit right with us. Now, I also want to caveat this. It's a very self-serving thing to say that, because we weren't at the frontier yet. We weren't one of those companies. And our mission always was to become one of those companies, or our goal was to become one of those. So as we kind of did some soul searching, we said, well, look, we actually do care about this. I would like to live in a world where foundation models are not something that's built by 3, 4 companies, even if I'm one of them, but it's built by hundreds of companies. Everyone should be able to build capable intelligence. The world itself, through democracy and others, should put the limits on what's allowed and who can do what. But I think a world where power is more equally distributed, particularly with technology. It's kind of like if we would be buying our electricity from 2 companies or 3 companies on the globe.
Yeah.
The fact, but there's a big difference between intelligence and these models, is that every single model inherently has a bias. It's the training data. And all of us, while we work from a lot of the same corpus of data, the web, we intentionally and unintentionally introduce very different biases in these models. And so living in a world where every end user has choice, they can say, I trust this company more, or I no longer trust this company, I want to go here, or their capabilities are not what I'm looking for, or competing on cost or anything, is a better world. And so we looked at, okay, how can we both succeed in that world, right? How can we build a company that is able to gather the resources to keep investing in these models? Because this is a very capital intensive business and we shouldn't ignore that. And how do we also kind of push the world towards one that isn't just 3 companies, but one that could be 100 foundation model companies? And so building open source models for us was the obvious choice right now to go for. I think there are open questions. Is open source a truly viable business model at the scale of capital that we need to deploy to build capable models?
Right. Because there's so expensive to train a model, and then open weights being effectively free. Yeah.
I think it's still it's unanswered. It's unanswered for us too. And I don't want to claim and say now we will be open forever in every way, shape, or form. What I can say is that deeply embedded in our mission, our culture now, is to try to push to a world where hundreds of companies can build this. And being open right now, sharing our research, sharing the weights while we're able to, while we're allowed to in this world, I think helps push towards that.
Yeah. And you're also an American open source lab, which is striking to me. Yeah.
It shouldn't be. This is the thing, right? I don't know how we ended up in a world where all of a sudden it is special that we are an American open source lab. right? It's, again, talking earlier about the dystopian sci-fi novel that we're reading, the fact that we have gotten to this place where people are surprised by the fact that we are putting out capable models and we are an American open source company shouldn't have happened. We should have seen an incredible flourishing of open source and of lots of different foundation model companies in this country. And not just in this country, I think in many more places in the world. And so we try to just keep our heads down and focused on building the most capable models that we can. I think ultimately this race is won by doing so. It's not won by trying to crown yourself king of open source or king of Western open source or adding another, adjective before that and saying, hey, this is where we're best. Ultimately, when I'm a user, I want the most capable model at the, most effective cost to be able to complete my task. But what is becoming interesting and where I think open source now has a real chance is that as we're making these models more capable, we are starting to take the economically valuable work we do, the knowledge work we do, the 25% of global GDP, and it's collapsing more and more in models being able to do the tasks of that work. And we're realizing that, hey, actually, as we're making models more and more intelligent, there's going to have to be a limit. And so if I had a whiteboard here, what I would draw is if you have on the y-axis model size, call it from, tiny model, 100 million parameter model to the very top one day, a theoretical quadrillion, parameter model. And today we're, at 4 or 5 trillion in the world. But let's say at the limit, infinite, model size. And then across the x-axis, you would talk about the return on investment of a token. And sitting here at base 10 for a business. We know by definition that the infinitely large model at some point is so capable and so intelligent that it's not where you're going to ask to do your accounting from, or it's where you're going to ask it. And we already see this today, right? Smaller models are highly capable of answering a lot of questions that before were only a year or two ago to the larger models. And why I mention this kind of graph of model size to return on token is that it means that if at the limit, no one is going to spend the most expensive token on the most expensive, largest model, it means there's somewhere an optimal point for every single piece of work that we do. An optimal point for a search query we ask, an optimal point for a piece of code we want to write, an optimal point for, progress we want to make on scientific research. And so this warrants itself that this is not an infinite model size race for everyone. And it pushes to commoditization. And the best example of that is this phone, right? We know that this processing power inside this iPhone before could only be imagined in the size of this entire building and not even.
Yeah.
Right. And so as hardware gets more capable, as we continue to squeeze more out of models, and that's why I'm excited about Laguna S, because it's a model that people, I think, hopefully will be surprised about how capable it is in its weight class. At least we definitely were. And this is why I do think open source can win. I think more and more of foundation models will become commoditized. And we will look back and say, in 10 years in that sci-fi novel, we'll be back and be like, oh my God, it was so cute that we thought that it took these massive data centers to be able to run these very big models, to be able to solve, accounting, or to be able to help with, writing code. That doesn't mean that we shouldn't be pushing to larger and more capable models, because the larger, more capable models push the frontier of science. They push the frontier of discovery. And that's going to frankly drive the vast majority of economic value for the next 100 years. But open source, I think, will have its place if we solve two things. One, if we solve the business model. I think it's still an open-ended question for it. And if not just us, but also others, frankly, start building an ecosystem here in America and in the West of pushing these capabilities more. It can't just be us.
So you wrote this article about this question of who gets to build intelligence. Can you talk more about that?
So for me, I think it's going to be the big question next couple of years. I think we're like a fork in the road. Do we end up in a world where we find ourselves with 3-4 companies providing all intelligence in the world to everyone else? with 3-4 different biases and 3-4 different off switches? Or do we find ourselves in a world where anybody who has the talent, the will, and the capital is going to be able to build it? And do we find ourselves in a world that we find with electricity, where we actually have a huge variety of people producing electricity? We have some large players, we have some smaller players. Or do we find ourselves in that world of 3? And for me, I think the window that we're in of making this decision, this fork in the road, is really small. And it comes down to the fact that we are starting to see that models are already having a meaningful impact in the progress that we're making on model development, right? And we talk about this broadly in the industries as RSI, recursive self-improvement. But even before recursive self-improvement, I think one of the reasons we're seeing such incredible progress on models, at least we're definitely seeing it at Poolside, is the fact that 90% of model building is engineering. It's writing code. It's analyzing data. It's looking at data. And this year, the capability increases that we're getting from models allow us to massively accelerate doing those things, right? The time that it takes to go from an idea in a researcher's mind to, a valid ablation to see, is this idea going to become part of the next model run, is compressing. It's massively compressed in the last 6 months, and it's going to continue to compress. And as we get to a point where the models are no longer just like power tools for our researchers and for our engineers to like do more, but they start becoming really autonomously part of the cycle of improving models. And in some places, they're already starting to do so. We're seeing some of our agents inside our model factory making progress. It's early, but it's clear that it's not going to stop. Then the function starts becoming compute. And so right now we're still living in a world where we as researchers and engineers are a big part of the function of progress. And the decisions we make are of how we've written our code, how we've built our infrastructure, how we built our model factory, are allowing us to speed up. But that world probably won't exist in 12 to 18 months. And in that world, if we haven't created a foundation and opened up enough of the research to allow more people to build foundation models, we're going to live in a world where all of us are buying intelligence for many years from a handful of companies that are not going to allow us to use that intelligence to build intelligence. And I think this was, for me, one of the most shocking things of 2026. The fact that we started seeing foundation model companies saying, no, you're not allowed to use what I create to actually improve what could compete with me. And it's their full right. It's a free market. And so it's not a judgment on should they be allowed to do this or not. I think they're a company that should be allowed to decide how people use their product. But it is still shocking to me that that's the world we're already in. And so I think this is a small window. And so for me, this is a little bit of a call to arms. Anybody who today has an either inkling of wanting to start a foundation model company, you have the background, the knowledge, you might be at a great company today, think about leaving, because you can actually make a meaningful difference in the next couple of years in ensuring that we are not just going to all be buying intelligence from a few companies with very little choice, who are going to determine what we're allowed to do with it.
You talked about what has surprised you about 2026. I think what surprised me the most is I've cared about, open weight models for years now, but it's surprised me how many people now beyond just this bubble are starting to really care and focus on open source AI. It's been incredible to see.
No, look, I think that fear of someone can turn off my intelligence, someone can make 80% margins on the tokens that are coming out of it, I think it's becoming clear to a lot of companies and a lot of people. But I think it's a trade-off, right? You, as a business, you are competitive by having access to the most capable intelligence that can allow your people and your businesses to do more. But what we're starting to see, that like the jagged shape of intelligence and knowledge work and valuable work, has a lot of places where open source now starts actually being more cost competitive. And ultimately, we have to win in a world of capitalism. Like idealism about like open source models means absolutely nothing if you are not able to actually show that you're able to have a better return on investment for someone who is choosing to buy tokens from you. And I think in a world that we're all compute constrained, because that's very much the case, the incentives for companies like us who are not yet at the frontier, we're working very hard towards that, is to actually allow our models to be able to spit out tokens at significantly lower margins. That's what open weight is effectively doing. And so I think we are starting to see that. We're starting to see businesses understand that. But I think we're in the early innings of this. And I think the world can go many different directions still. I don't think it's determined yet what the future looks like.
What's been interesting or surprising about using this model?
So one of the favorite things about being on the inside of building models is that you get to vibe check your models and all the different variations before you release one of them. And so I have admittedly spent way too many hours doing this in the last 10 days as we finished our post-training, to the point where my partner told me, you can no longer be in bed with the model, which I think is the only time in history that someone actually intended like what I was saying here. And so for me, there were a couple of things that I really enjoyed. One is I threw the Erdős 397 problem that OpenAI solved at the end of last year to this model, knowing that we were in the window of cutoff date, that data wasn't going to be inside there. And in 30 minutes, it solved it. And when you throw math problems at Laguna S, you see that it will reason and think for a very long time because they're complicated theorems and to do so. And so seeing 118 billion, 8 billion active parameter model solve what to its own knowledge cutoff date was an open, complicated theorem, and doing so in half an hour of inference and just reading the thinking traces, seeing how it spends the first 20 minutes going down a path that's wrong, but then finds a different path, corrects itself, and ultimately solves it, is like, it's very humbling, because I would have never predicted that a model of this size will be able to tackle a problem of what from the outside looks at such a magnitude of complexity. And this has been one of my favorites. My other favorite was I run a call transcription tool like many other people do on my laptop. And so I wanted to see if it could extract the transcripts that were stored in there. And so the model, and with the agent, with Pool, went off for about 30 minutes. It found the encrypted database on my laptop. It realized that it wasn't able to decrypt it because it didn't have the password. And it attached a debugger. It launched the application on my Mac. It attached a debugger to it. And it was able to extract from my system's memory the actual transcripts. And that's one of those tasks where, being a software developer yourself, where you see that level of persistence, it's not able to figure out how to get into the database, and it goes and tackles this and then finds out how to do so, it's incredible to see. And now look, obviously, you treat models a little bit like parents treat their children. Like, you look at them and you're like, you're perfect, even though some other people's kids are way smarter and way better than yours. So we've got some work to do. But the size of this model in relation to what it's able to do has been, for me, an eye-opener. And I think it's an eye-opener because when you know how the sausage is made, you know how much better you can still do. And it really poses the question of how much more can we get out of the parameters, the weights and activations that we have in the models that are out there. And I suspect that we're going to continuously look back on the next couple of years and say, oh, wow, we're now using these incredibly large models to do X, but all of a sudden what before took a trillion parameter model now can be done with a 200 billion or 100 billion parameter model. And I think that's encouraging for a world where intelligence becomes more commoditized, becomes more open source.
Yeah. Absolutely. Well, Eiso, thank you so much for being here, and I'm really excited about Laguna S.
Thank you. Appreciate it.
Yeah.